Okay, I'm going to give a brief intro to cylindrical coordinates, which I just like to think of as polar coordinates with a z. Um, and I'll explain why. Basically, you just do not do anything to z. If you start with x, y, z, you just do nothing to z. And then you just change x, y to r theta. And that is what cylindrical coordinates is. Yeah, it doesn't sound that profound, but it's useful because there's a lot of situations where you have cylindrical symmetry about some axis. I can just name a couple. Like if you take electricity and magnetism, then there's just a multitude of homework problems that you'll get involving integrating electric fields, magnetic fields along cylinders. I did work in fluid mechanics where the setting was a pipe, and you have a fluid going through the pipe, and um, well, you can simplify the problem considerably by just using polar or cylindrical coordinates. Um, Really, the idea is that as soon as you have extra symmetry, the problem gets simpler, so it's nicer to use good coordinates. And these are no exception to this idea. So, for example, the cone z equals x squared plus y squared square root, it's kind of complicated in xy coordinates. But as soon as you use cylindrical coordinates, it's just z equals r, and cylindrical is now r theta z. Okay, so you'll see that there's no theta dependence here. And we could actually plot this in a 2D plane. So plot as a 1D graph or in a 2D plane. What was originally a 3D space, and this was a 2D surface. So we reduced the dimension by 1. So here's z equals r, zr, and you see now it's just now we're back in 1D land. And that's a good thing. That simplifies analysis quite a bit. I mean, just to appreciate this, it's easier to draw this curve than a surface, right? And that's just one of the benefits you get by this dimension reduction. I mean, you can appreciate another example if you just look at the area of a disk. When you do that integral, right? If you do the x and y integrals, the y integral will be something like minus 1 minus x squared to plus 1 minus x squared, and this will be negative 1 to 1. And that's hard, right? But if you do polar or cylindrical coordinates, I guess polar in this case, really what this is now is just 0 to 2 pi, that's your theta, and this is 0 to 1, that's your r, and this is your r dr d theta, and now you can't split. And by split, I mean in the sense that when you can split the theta integrals and the r integrals. So this is now a 1D integral. This is now a 1D integral. So it's no longer an iterated integral. So now it's just two 1D integrals. I mean, you know this already, but I'm just trying to illustrate that whenever you have this symmetry, good things always come from it, and it's usually in the form of a dimension reduction. And because everything we know is 1D, that was the calculus course we did before. This will then be a lot easier to deal with instead of multi-dimensional stuff. Okay, thanks for watching.